Okay guys, in this video lesson we're going to cover what happens when your pulling force or your applied force does not equal the exact direction of your motion. Okay, so it's pretty common actually that when you push or pull on something that you're not pushing and pulling 100% parallel to the movement. Okay, take for example, you want to push a stroller with a kid in it. Usually the bars are above the stroller. You kind of push somewhat down and somewhat forward, and that makes the stroller go forward. Okay, or maybe you're pulling a sled in your around the neighborhood with your buddy in it, your little sister in it, that kind of deal. And as you pull, the string comes up at an angle towards you, but you're pulling the sled horizontally across the surface. Okay, those are all very common kind of things. When you're pulling trailers on trucks and vehicles, that kind of stuff, they try to get the angle that the truck pulls, where you hook up to the truck to the trailer, to be as parallel as possible with the trailer. And there's a reason for that, because when you're pulling things or pushing things and your applied force is not parallel to the movement, you're wasting some force. It basically means you're wasting some energy. Okay, so what happens if the force is not in the same direction as the traveler? Okay, we need to take a look at this from the perspective of, okay, if friction is pulling us backwards here, and we have force of gravity pulling us down and normal force pulling us up, when we pull at an angle, only the parallel force, so not the entire force you're using, only the horizontal component of that force actually contributes to the movement of your object. Okay, if the object is moving horizontally, only the horizontal component works. Now, if the object was moving vertically, only the vertical component of that would work in terms of this example. Okay, so what we really need to do here is just a little trig. Okay, so it's no different than before in two-dimensional motions. We basically set up our vector diagram or our free body diagram, recognize the forces all happening on it, and if it's at an angle, we have a theta, or we have an angle, and we just need to use a triangle and solve for our angle. Now, the nice thing is we always want to solve for the leg that is adjacent to the movement. So we're going to do cosine in this case. If our movement is left to right, we're going to do cosine of our theta, and that's going to get us to our answer. Okay, so using SOHCAHTOA, we basically would use cosine here to solve for this. Okay, makes it nice, so we're just going to use cosine. Now, on the board, I have a problem for us. All right. So what we have here is we have a block, and let's just assume that that block is sitting on some sort of surface. Okay, the surface to block friction at a maximum amount is 45.2 newtons to get it to move. So we have to overcome 45.2 newtons on our block to allow it to start to move if we're trying to pull it and get it to move in this direction. Okay, so we want it to go this direction, but we need to be able to apply 45.2 newtons. Now, this block is sitting on the ground, and I am standing up here, smiling away, for the one box, and I'm holding on to the string, there's my big hand, ready to pull, okay? So as I pull in this direction, it comes up as an angle that is 37.5 degrees from horizontal. So I need to figure out how much force do I need to pull at this angle so I can counteract the 45.2 newtons on my object, okay? Now, we have a force of gravity of negative 375 newtons, and we have a force of normal of 375 newtons. In this problem, this data doesn't really matter, because all we're solving for is what is the horizontal component of this thing, okay? So for us, we're going to basically say, I'm going to take my applied force times the cosine of theta, okay? That will equal my force that is adjacent here, okay, to what we have to see what's going on. Well, we know that friction is pulling back. I'm going to make this a negative sign. So it's against the motion, so we'll call it negative 45.2 newtons. So the force that I want to apply to get to move in that direction would be 45.2. Okay, we know cosine and theta is 37.5 degrees. So what is the force that I'm applying? So we don't know this, okay? And now we can solve. So what I do is take 45.2 divided by the cosine of 37.5. Again, making sure that you're in your degree mode in your calculators. So 45.2 divided by the cosine of 37.5. And it gives me an answer of 56.97, or basically 57 newtons. Okay, so for me to be able to move this block that's getting held back by 45.2 newtons, okay, I'm going to have to apply 57 newtons in this direction, so I get a net result in the horizontal direction of 45.2 newtons horizontally, okay? So it's one more step, okay? So it's not like we have, a lot going on here in terms of new information. It's just realizing that before we've always kept everything parallel. So now we need to deal with the fact that it's not always parallel, okay? So here's another practice problem for us. We have a 45 kilogram block, sits on a frictionless surface, okay? So now it's frictionless for us. Pull with a force of 35 newtons at 30-degree angle, okay? So now we know the pulling force. So if I set my problem up, I have a block sitting on a frictionless surface, so there is no friction. So no friction force. Okay, none of that. Okay. Pull with 35 newtons. So let's pull it at 35 newtons at an angle of 30 degrees. Okay. Above the horizontal. So it's pulled up above the horizontal. Okay. What's the acceleration going to be? Okay, so we gotta know what the acceleration is. Well, we know that the weight, or the force of gravity, is our mass times our acceleration. Okay? Downwards, we know that the normal force will counteract that. So this would be negative and this would be the positive value of it. Okay? We know we have a 45 kilogram block, so our mass is 45 kilograms. Okay? So well, the first step in our problem is, well, we need to know what is our force that is going to be in the horizontal direction. Okay? So let's solve for force that's horizontal, first of all. And then we can plug it into our equation. Now we don't need this because we're not moving up or down. What we need to do is say, well, the force is going to be mass times the acceleration. Once I solve for horizontal force, I can put into F. I know my mass. I can put into AM. I can solve for the acceleration left to right. Okay. I make a note of this because sometimes students, when they get to a problem like this, they assume that the acceleration is 9.81. Remember, that is not true because we're not moving up or down. We're moving horizontally here. Okay? So go ahead and do that. Let's take this. We know the force that we're applying. We want to know what the force would be horizontally. So again, use cosine and solve it. Once you know your horizontal force, plug it back into your equation and solve it. Okay? So do that now. Do that on your own. Okay? So pause the video here. And once you get an answer, then continue on from this point, and we'll show you the answer key to this one. Okay, so pause it now. No, really, pause it now. You still haven't paused it. Pause it now. Okay, if you pause it or not, I can't really tell. So here's your answer. We'll take a look. We know it's our force net is mass times acceleration. Okay, so what I did is said my net force is going to be the applied force times the cosine of theta. So I actually put that into the equation, which means my applied force times cosine theta is m times a. My applied force was 35 newtons. I had a cosine of 30-degree angle divided by my mass, and I got 0.674 meters per second squared. Okay. Now, what if your applied force was horizontal? Could I just use this equation every time? Do I need to get rid of the cosine theta and determine when do I use it, when do I not use it? Well, let's find out. If our applied force was this direction, we would have no angle. So our theta would be 0 degrees, okay? What's the cosine of 0 degrees? Well, if you don't know that, let's check it out. Cosine 0. Oh, cosine of 0 is 1. So we're basically saying that if you pull at the same angle as you're moving it, no angle, no degrees, you're going to get 100% of your pull is going to count, because we have cosine of 1. So yeah, actually, you could use this equation all the time, and then anytime you are pulling parallel with your movement, you just say cosine of 0, and that becomes a 1, okay? Another way of looking at it, if you want to. All right, guys, that's all the new stuff we covered today. That's it. Thank you.